Is it audio only or video as well?
It's video as well.
Okay, so we'll go out video.
Oh, yeah, yeah. You're
Okay,
looking
cool.
good. You're looking good.
Lucky I had my beard trimmed recently. It was getting pretty crazy before.
That's always important, man. My wife's always complaining. I can't even grow a decent beard here.
My wife is not keen on this beard at all.
No?
No, not even at this length. No.
For me, it's the sideburns. I can't remember the last time I shaved off my sideburns. So it's probably accidentally one time. It just look hideous.
We got to protect ourselves, man.
Definitely. Hey, Stephen, thank you for joining Couch Confidentials. This was kind of an off-the-cuff invite because I got an invite, I received a question from someone through LinkedIn and who had some questions around what are the capabilities of using AI in identity resolution. And the first person I thought of was you because we had spoken to each other before around Tilores. And yeah, I think you are the perfect person to answer this question and to dive a little bit deeper into that topic. So for the people who don't know you, can you do a quick introduction about yourself and about Tilores?
Sure. Well, first of all, thanks for inviting me to chat. This is definitely a topic I'm excited about. Yeah, my name is Stephen Renwick. I am one of the co-founders and the CEO of Tilores. We are a entity or identity resolution company. So for those of you who don't know, I presume most of your audience is familiar with identity resolution, but briefly, we deduplicate and link record data in scale, in real time, for use cases that are ranging from marketing to fraud, compliance, risk. Yeah, a very kind of general purpose entity resolution technology.
Excellent. And what kind of markets are you focusing on? Because I remember during a previous discussion, you gave the example of a telephone company who's been around for decades, probably even, I don't know when exactly when Alexander Graham Bell invented the phone, but let's say 100 years. What exactly is the role of Tilores in that case when you've got customer data spread out across tens, maybe hundreds of legacy systems?
Yeah. I mean, the telecoms company is a classic example because telecoms companies are the results of multiple mergers. They have multiple data systems internally, and they have customers that quite regularly sign up with them, create accounts. Maybe they're using a SIM card just for a year or so, then create a new account, and they struggle to get that single view of their customer. And this whole problem of linking that data together to say this is the complete picture of this customer is maybe something that doesn't sound too difficult. But actually, and it's not so difficult if you're doing it deterministically. So if you're just saying, hey, they got the same email address, fine, that's effectively a unique key. You can match them based on that. But that's not how real world data actually looks. Real world data in these situations is complex, it's messy. People change email addresses, they put different versions of the email address in, their name gets misspelled, their address gets misspelled, they change address, etc., etc. So actually doing the fuzzy matching on this is difficult. And it's especially difficult doing it at scale because it's a quadratic problem, which means the more data you have, the number of comparisons you have to do is scaling quadratically, more than logarithmically. And every single new record that you want to compare, in theory, has to be compared to every single record within a data set. So it's something which is extremely difficult to do at scale. It's extremely difficult to do in real time. But those are the things that we kind of specialize in. Highly accurate, highly explainable, and highly performant data matching.
Yeah, no, the phone company situation, it does sound very common. I know here in the Netherlands, if I'm looking back about 15, 16 years ago, there was a period where it was cheaper to get a new subscription every year, kind of switch between carriers so you could get a new phone. Because at the time they were just giving away phones with your subscription. Of course, it was built into the price of the subscription. But anyway, and it was just cheaper to kind of switch back and forth just to get the latest phone. Yep. These days, it's a little bit more different. You rightly pointed out. I'm a SIM only. Where we are a SIM only family at the moment. We don't, we'll buy the phones separately. So, and the amount of records, T-Mobile in the Netherlands has switched to a different brand name, Odido. I think they even merged with another carrier here in the Netherlands. So that example that is very obvious. But when we look at the technology around AI and identity resolution, so without AI, identity resolution it is 9 out of 10 times it is deterministic. We used to have DMPs, but we would try probabilistic approach to say I didn't get too deep into DMPs, but I think it worked on browser fingerprinting, really trying to get an idea of all the extensions you had installed in your browser and your IP address, your other user agent data. And from that, it would create a kind of a key that it would try to identify you at a probabilistic level across various networks. How does Tilores kind of take that challenge to the next level with AI?
So I'll have to take you a step back there, because we almost specifically do not use AI, right? So, and I'll tell you why, because it's very often the first question we get. Our technology was originally developed for kind of a regulated industry. So we came from the credit bureau industry. Many of our customers now are in regulated industries, insurance, finance. And one of the biggest requirements or most important requirements you have for matching customer data is that it's explainable. Not just that it's explainable, that it's also reversible and auditable, that you can delete individual records. And the problem here is that this data can get very complex. It's not just about connecting record A to record B. That's a kind of a simple example. What we do is we actually form graphs of data, which can themselves have hundreds or sometimes thousands of records in them. If you're connecting lots of different systems, if it's complex data, you can have these very complex graphs of data. And you can imagine each record is a node. So A is connected to B, and B is connected to C, and C is connected to D, etc., etc. But that means D and A are not directly connected, but they are considered the same company, in the same entity. Now, when you have these kind of complex entities, you need to be able to manipulate them very accurately. So what Tilores actually uses is a rules-based system. The question is whether it's deterministic or probabilistic. It's more probabilistic than it is deterministic. We're using the common algorithms that most people will have heard of, like cosine similarity, Levenstein distance, various phonetic algorithms, distance matching. We've got a very extensive kind of data transformation and normalization module to clean up data, because it inevitably comes in different formats from different sources. But in the end, what you have is a rules-based system where you have anything, I don't know, maybe we need 10 and 20 rules, which say, okay, if the first name is similar and the last name is similar and the email address is similar and the postal address is similar, then that should be, those two records should be linked together. Yep. One or more rule being triggered forms the connection between the two records, a so-called. Now, the important thing is, in the actual data,
even on a single rule,
on a single
email address, yeah.
With Tilores, it's completely customizable, so you can make it as strict or as loose as you want. So we're always measuring so-called precision and recall. So you're looking for false positives and false negatives, and it's always about difficult to reach 100% on both of those. But it depends A, on the quality of the data, and B, your use case. So if you want to be very, very strict, you want to have 100% precision, so there's no false positives. If you're coming from a credit bureau, that's super important, because you cannot have a mix-up on data and the wrong person getting a debt collection letter. If you're doing entity resolution for fraud detection, then you're actually wanting to make the rules quite loose. So you're intentionally looking for false positives, because you want to be connecting related people together to say, these people are some kind of network, which suggests is they're either one person pretending to be multiple people, or they're a group of people that are acting together to defraud. So when we connect the data together in the entity graph, the actual data structure itself, you can see which rule was triggered. So you know exactly why A was connected to B. And that's super important, because regulators actually care. If you're in a regulated industry, a regulator will actually say, okay, did you match that because the cosine similarity was 0.8 and blah, blah, blah. I'm not saying they're all like super entity resolution nerds, but they know why.
That's you here, Stephen, not them.
Yeah, I'm the nerd here. But you should meet my co-founders, they're the real nerds. But really, they will understand, and you have to be able to defend it. The other advantage of doing it a rules-based method is that you can make very good iterative progress. You can see that if you tweak this rule, change this threshold, fix this normalization, you can see the precision creeping up and the recall creeping up. Whereas if you take a machine learning approach, and to be upfront, we have machine learning in Tilores as well. If you take a machine learning approach, it's much more black box, right? It's probabilistic. Yes,
Yeah.
it'll give you it gives you fast results. Like getting set up is much faster. But once you're there, it's very difficult to say why you're matching A to B. And you don't have this very concrete evidence of why you're matching two records together. So it takes always a bit longer to get Tilores set up for a rules-based system than the ML system because you have to configure it. Obviously, we have kind of templates based on the data. But ultimately, we find consistently that you get better results. The challenge for us is just explaining that to people because everyone assumes it will be AI. And actually, even with the machine learning, we add in kind of rules-based matching as well. So we can set up a machine learning matcher and say, okay, if the machine learning algorithm says that there's a match, you combine it with a email matcher. So the email address has to match and the machine learning rule says it's a match or something like that. So you can combine it in, but 9 times out of 10, we do it based on rules. Now, the next thing you might be interested in is what about if you just give it all to a large language model? So you can imagine we get asked that a lot as well. Isn't GenAI just going to replace what you do? Obviously, the answer from my perspective is no, and I'll tell you why. Oh, actually, it's yes and no. But I'll tell you why. So LLMs, if you give them two records, they're pretty good at saying, do you think that this record and this record belong to the same person? Like, no question, they're good at that. The problem is, there's a few problems here. First of all, there's consistency. With a rules-based system, if I take 100 million records, put it into Tilores, and I do that again, I delete all the data, and I do it again, I will get exactly the same results every single time.
Fixed ruling. Yeah, no, I see where you're going with this. Yeah.
With an LLM, you do not have that. And on the obvious cases, yeah, of course, it's going to say that Stephen Renwick is the same as Steve Renwick in Berlin, blah, blah, blah. But that is not what real world data looks like. Real world data is the edge cases, the messy stuff. And that is where it becomes tricky to trust an LLM because you basically get different results every time you use it. Speed is an issue. Like it takes quite a while to, obviously an LLM takes a while to do something like that. Cost is an issue. And then there's other things like LLMs don't understand the temporal nature of the data. They don't understand relationships of the data. They can't handle the graph relationship of the data. They don't care that there's multiple different records in here. They can't understand that A is linked to B and B is linked to C. See, that kind of graph nature doesn't work with LLMs.
No, but I think still the key feature is the first one you said is consistency. If you're in your own OpenAI account and you open up 10 chats and you put the same question into each one of them, you're going to get 10 different answers. Yep. So there's no reliability here. And especially if you take it all the way back to that piece about accountability, being able to trace where a certain decision comes from, your whole product fails. So I fully understand now how AI cannot be dependent on those kind of situations.
I'll tell you where we do see potential for it. Like we use LLMs with Tilores, so we're not like some kind of GenAI Luddites. We believe it's an incredibly exciting technology, but it has to be used in the correct way rather than just saying, "Hey, we do GenAI." So for actual entity resolution, where we do see a potential is as an alternative to a human in the loop. When you're doing all this matching. Yeah, but the potential. You will have obviously the edge cases where you're not 100% sure if it's matching. The threshold for being unsure depends on the use case. And so what you want to have there is basically a queue of questionable matches where a human can review it, but you could also subcontract that to a large language model. Now, the question is whether you're taking a bit of a chance by giving your maybe highest risk matches to an LLM rather than letting the human do it. But that's something that we've done a little bit of testing on. It seemed to be quite good to take some of the workload from a human. So we have this idea that an agent in the loop could complement a human in the loop.
Yeah. I've been testing with that as well with a project where based on CVs, we're trying to extract the postal code because they want to target hiring campaigns or at least job application campaigns by postal code. Let's say a client lives in postal code A. They want to target all the candidates that live in and about a specific region. But a lot of the resumes and CVs that they receive often don't include a postal code, or it's very sketchy. Everyone has their own version of Word, or they leave it in a Word document or put it in a PDF. And what I've been using LLM for in that case as well is to kind of read through the resume and find anchors of where this person has done an education or previous work experience to try and determine the possible location and determine the first part of the postal code, just to keep it a little bit more random and anonymous. So there are definitely uses for that to further enhance the data or try to extract certain values based on other how should I say it? Hints or traces or what do you call it? Breadcrumbs. That's the word I was looking for.
That's something else that we think could be pretty good. We haven't done so much of it ourselves, but like entity extraction. If you have documents and you want to know who it's about, we don't do entity resolution on unstructured data. It's always structured data. But if you could get an LLM to do the natural language processing and kind of extract that this court record is about this person, then you can do entity resolution on people that have been in court, for example.
Yeah.
That's one example that we've been kind of working on with a partner recently. Yeah, lots of great opportunities for LLMs. Where we also find it quite useful is as a interface for the data itself. So Tilores is primarily an API to API system. Most people are not looking at Tilores. But we do have a UI. Usually that's used for configuration, but we also get more and more people that want to use it as kind of like an analyst interface. Now, if you do an API query in Tilores, it's a GraphQL query API, so you can restrict how much data you get back, because sometimes that can be a ton of data about a person. But the beauty of GraphQL is that you can configure what data you get back. But the other thing you can do is use an LLM to query the data. So do the query in natural language. The LLM converts the query into GraphQL query, and then you get however much data back you need, and the LLM changes the data result back into natural language. So we have found that is pretty helpful. It's pretty helpful in sales, to be honest, because if you show the business people that, they're like, wow, I can talk to my data. And yeah, so that works pretty well. And we then started positioning that as identity RAG. So can Tilores, or an identity resolution system, be a so-called retrieval augmented generation system for large language models? Turns out it works pretty well, because what you need for RAG, you need search and context. Our entity resolution system is a search system. You first of all have to search for a specific person. You then need to get as much context about that person as possible. Works very well. What you don't want to do is be using a vector database for identities, because there's just too much chance of kind of overlapping with other people. So for specific use cases around getting data about specific people, and where that person's data is probably spread across multiple systems, and you want to update it in real time, an identity resolution system works pretty well for that. So we've had success using LLMs on top of Tilores.
And quickly coming back to the vector-based versus RAG, why could you dive a little bit deeper into the benefits for RAG over a vector in that situation? I mean, maybe also an idea to mention kind of average database size. I mean, what kind of size of data are we looking at? Because I know that makes a difference, especially between cache augmented and retrieval augmented.
So the problem with, the vector databases are fantastic, I think, for the unstructured data. But if you want to say, tell me about this specific person in your GenAI application, you need to be very certain that you're retrieving the data about the correct person, and that you get all the data about the correct person. Now, if you do that in a vector database, and you've got two people that have got kind of similar identities, then according to the vector database, they're quite close to each other. So there's a pretty strong chance that you get this overlap of the data which is retrieved of two people. And of course, a vector database has no concept of graph structure of data. So it can't do this multi-node hop to retrieve all the data about a person. It's
just tokenization of the data that you push into it.
Exactly. So I'm not claiming in any way that what we do replaces a vector database, but we think the best approach for certain use cases is to use the identity resolution system as a source of data about the specific thing you need to retrieve the data. And then you complement that with the vector database. So the vector database is filled with everything unstructured. But if you want to say, tell me about the insurance policy about Stephen Renwick. You want to make sure that you're retrieving the data about Stephen Renwick. It tells you about, did you mean this Stephen Renwick or this Stephen Renwick? It knows what insurance policies I've got. It knows how long I've been a customer, et cetera, et cetera. And then the unstructured data is the policy documents, which belong in the vector database. So it's about just using the right tool for the right job.
Interesting. Besides telecom, what other industries do you see this flourishing in, I have to say?
Well, I can only tell you we seem to be doing well. So logistics is a big one for us. Imagine you're a logistics company, you're delivering packages for retailers. Each retailer sends you the address in a completely different format. So you have 200 more different data sources, and eBay gives you the name in a different way from Amazon, a different way from Temu. So they cannot build a single view of customer. That has been pretty successful for us. General kind of financial services sector, I'm not going to claim we're in any tier one banks or anything like that yet, but we have quite a few kind of fintechs and smaller finance companies using us. There's the general customer 360. So we're working with one of the biggest publishers in Europe doing customer 360 generation for them.
I mean, publishers are legacy as well.
Yeah, they've got tons of data. They've got years worth of data from multiple different publications or data sources. They might have offline data sources. They might have people signing up for lottery tickets or something inside a shop. It's like
call center data.
Yeah,
they keep
exactly.
on calling for subscriptions.
Really classic data. And unless you've got a pretty good identity resolution system, you're not going to be able to build a single view of the customer. We're also in supply chain risk. So that's when you're doing entity resolution more on companies, or entity resolution on companies more so than people. And turns out that's a lot more complicated than doing it on people. But that works pretty well as well.
Yeah, so two questions that pop up. The first one is, you mentioned that the whole UI, you want a user interface so people can actually start interacting with the system. Completely understandable, because as I've experienced with CDPs, it's very abstract. Yep. You are working with data, but you don't actually see the data. You're collecting it, something is happening in the background, and you can connect it to other systems, but basically everything in between, if you don't have a UI on top of it, you have no idea what's going on. And that's something I want to dive into a little bit more. Well, let's start with that, because then we can keep the topic separated clearly. What was so you mentioned that analysts, but you also mentioned that it helps with sales. How quickly, when you do kind of go through these sales processes, do you work with demo, or are you quickly able to set something up with the potential customers themselves with their data? I mean, there are some rules around that on making sure what you do with it. But
so the reason we created the user interface in the first place was primarily to make the setup easier. Like we initially had no user interface. It was purely API to API, and you had to create the entire configuration in JSON, and it was extremely difficult. So the UI was built, first of all, to help us. Yeah. It then became like a visual rule builder. It then became a place where you could look at the identities themselves. Something I should kind of explain about the way our hosting works, because that's very relevant for the data. We are today a kind of an AWS native application. So we run on AWS serverless. That's what makes it super scalable. But we have two options for deployment. You use our managed solution, which contains which has the user interface, and we're running the infrastructure, or you install it into your own AWS environment. The data never leaves your AWS hosting. We can't see the data, but you don't get a user interface. It basically becomes a data tool within your system. We are actually going to make it soon possible to have a UI even on self-deployment. But that's important because the data topic is, we're working with sensitive data. We're working with your customer data.
Regulated industries, like you said.
Exactly. And usually, we go into a normal kind of contractual arrangement with the customer. We don't get all the data. We get a sample of the data, enough to configure the rules. We normally do the rule configuration for the customer and then give it to them to ingest all of their data. And then assuming the data is a similar kind of standard and quality, then the same rules should work on the whole data set. In terms of the demos, the UI is great for a demo because it just shows the graph structure of the data. You can show how quickly the searches are going on. The LLM interface is inside Tilores' UI as well, so you can chat to the data once it's in there.
Yeah.
I'm not going to pretend this is a quick setup for Tilores.
Now you mentioned that, I can imagine there's so many.
Just basically getting the rules configured is we have to do a POC with you. And it is, in theory, you could probably do the whole POC in a week. But the reality is when you're working with enterprises, they've got to get access to their data. That can take a while, data from different sources, etc. They send the data to us. We do the first configuration of the rules. We show them the results. We do some iterative improvements.
Yeah.
And
but
yeah.
That brings up an interesting question, though. How do you define high level quality, and how do you monitor quality? Because is this done from the perspective of this is what it should look like, or we have some demo profiles in our system that, if the configuration is correct, should result in this? How do you approach determining what a high level of quality is?
Yeah, it's actually super difficult because sometimes we don't get the data at all and we have to do the configuration blind, which is very tricky because making this work well is understanding the nuances of the data. Yeah. If you're lucky, the client has labeled data. So they have a sample set where they know what is meant to match together.
Yeah.
Interestingly, we were doing a POC recently where the sample data or the labeled data was coming from another MDM system which they had used for the matching that they weren't happy with. And we were basing our precision and recall based on the results of the matching from that system. But it turns out that when we looked at the data, they had made quite a few false matches that we were able to detect and point out were inaccurate. So pretty cool.
Yeah.
But you in can, yeah, I know. Like, hey,
brush that off. Yeah.
Polish the fingernails. So in an ideal scenario, they've got a reasonable amount of labeled data. You use some of it for the training and some of it for the testing, and we can say this is the precision and recall we hit. Most of the time, customers don't have labeled data because that's kind of the point, right? They are unable to label the data because there's too much of it. So in that case, honestly, we end up kind of doing it manually just now. So we will run a data set in Tilores. We'll look for what we think are the edge cases, and we have to say to the customer, do you think these two are the same person? Do you want these two to be the same person? Do you want these two to be the same company? Because often often we find that you ask the customers and 2 or 3 different people in the company will give kind of different answer. Yeah. There's always like a data expert. There's the people that understand the data engineering. There's people that understand the data science. And then there's the people that understand what do we actually care about from the business point of view. And ultimately it's them that have to really give the answer. And then once you kind of get set up, once you got the rules configured, everybody thinks that they're going to be tweaking the rules here and there and trying to improve it. And in reality, people seldom change it. As long as the data stays the same quality, you don't need to change things. If you add a new data source, you don't necessarily need to change things, but you might want to tweak it. So we try to encourage our customers at least once a year to kind of do like a review and like an audit of the data and just make sure that we're happy with the matching performance. We don't have anything built in just now to do like matching to any kind of like performance on the matching quality, because unless it's labeled, you can't really do anything.
I smell an LLM opportunity here.
Yeah, it could be. You could be doing like samples via the LLM. He does the LLM agree
or unlabeled data to try and see, hey, what do you think this data type is, or what it's meant for?
Yeah, we're hoping to maybe work on that to make the assessment of the entity resolution a bit more transparent and a bit easier. Yeah. Otherwise, it's just a tricky thing to do.
So here's a question that's been burning on my mind. As you know, I work mostly with marketing technology solutions, CDPs, CEPs, where user profiles are key. How well would Tilores play with these kind of systems? I know you guys have an API. You probably can also work on top of a data warehouse. How could we get these systems to work together if I had such a project lined up? Asking for a friend.
Asking for a friend. Yeah. So, I mean, I think the way Tilores works best is when it's the upfront part, right? It's best if we're ingesting the real-time data as accounts are getting created. Tilores is not warehouse native, right? We are a layer outside outside your data warehouse. We can connect and synchronize with your data warehouse perfectly well. We've done that with Snowflake quite often recently. But data warehouses are not great for real-time use cases. Tilores is built for the real-time use cases. So you can keep the whole thing synchronized with a data warehouse, but really, ideally, you're pushing the live data as it's created into Tilores from whatever different sources. And then,
so and paint that picture real quickly so that you have real-time data coming in. You guys will do a check to see of the 10 legacy systems that we have connected to us. Who do we think? Do you guys enrich the user profile from that point on, or what does that look like?
So you've got to imagine that these entity graphs, the resolved data, is pre-calculated in Tilores. So if you've got 10 systems connected to Tilores and my data is in those 10 systems, then in Tilores it's already connected together. So it could be 10 records, it could be more. Yeah. And when a new record comes in, the first thing that happens is a search. So you search to see, is there a record within Tilores which looks like this new record which has arrived? Yep. Now, if I create a new account, I may be connected to one or more of the existing records in that Stephen Renwick entity, and then that will be inserted into that entity. If I find nothing, then I will create a new entity. So that's, in a nutshell, how it works. And yeah, it doesn't, kind of beauty of it is, doesn't matter if you're ingesting 1 record a minute or 1,000 records a second. This all can happen in parallel. Also can do bulk, right? There's no problem with ingesting bulk data. It's just real time can do bulk. Bulk can't do real time. So yeah, we're pre-calculating those entities. And also those entities can be synchronized back to the original source system. So each entity has an ID, an entity ID. And if you want, you could be pushing those entity IDs back to your data warehouse or back to source system. So in your data warehouse, it's quite common that you'll say, okay, we have these multiple records. And according to the Tilores entity ID, these are the ones that are related together. Is
that a case you see often? That because there's a lot of word. I mean, the terms that I've seen is golden record, diamond record, single source of truth. Do you want everything to be resolved and hosted in a single location, a single source, or do you also get requests from customers? Well, you probably do because you have that feature to sync the correct data or the new data back to its original source.
They usually want it synced back to the data warehouse. For sure. Back to the original sources, no.
Okay.
If it's like normal databases and stuff, they don't normally synchronize the ID back to the databases. They do very often want to synchronize it to the data warehouse. Yeah.
Oh, interesting. All right. Hey, what other you also mentioned fraud. The first time I spoke to or got into touch with companies that had kind of fraud protection. I'm trying to come up with it. It's called, I can't come up with it now. It was an IBM tool, not Sitecore, not Site Catalyst. It was called something else. And what it was an HTTPS sniffer or HTTP package sniffer. So what it would do, it would sit in between as a layer between your website servers and the users, and it would just copy the traffic that went back and forth. And they would use this. Why can't I remember the name of that? That's shameful.
It's an IBM company?
It was an IBM company. They eventually got acquired by IBM, and now they're being sold as an online version through, and I think they've sold it off again, and now it's a standalone solution again. I'll come up with it here in a second. T-Leaf. That's nothing with Site.
T-Leaf.
Yeah. So there was a solution called T-Leaf.
You know, T-Leaf is Cockney rhyming slang for thief.
Well, they did do fraud protection,
there you go.
At least fraud detection.
I wonder if they were from East London.
Might be. I don't know. Is that so? Yeah. T-Leaf is
Cockney rhyming slang is is the kind of the slang talk in East London, and Cockney rhyming slang for a thief is a tea leaf.
Oh, that's interesting.
He's a tea leaf, governor.
I can't even do that. I used to watch Only Fools and Horses for a long time. Anyway, but so there was this tool called Tea Leaf, and that was also around like 15 years ago. I was working at Thomas Cook, and they would actually use this to and the way they sold it to us is that you can actually use it for fraud attempt detection. So if somebody wanted to use multiple credit cards during a single session, for instance, to book a holiday, you could flag that automatically and have it reviewed by the fraud detection team within Thomas Cook. So it was pretty interesting at the time. And I think there's also Celebras has some kind of solution right now. They also do fraud detection. Yeah. What are the cases that is fraud detection kind of the biggest use cases you come across right now, or at least that you're being used for?
I'd say it's about a third. It's not the biggest. It's basically looking for people that are creating multiple accounts and pretending to be different people. So we're doing the entity resolution.
The
based
average
on
engineer testing their application.
Yeah, exactly.
Yeah.
Yeah. Oh, I mean, don't get me started on that. That's a different topic, but the amount of test data we see is insane.
All these test accounts being
All
generated?
the test accounts, that cause massive problems because nobody deletes it. But when you do entity resolution on test data, it's all related. So you end up with extremely complex, massive entities on big companies filled with test data. Anyway, I digress.
No. One thing I really wonder who's the owner of test.com.
Yeah, exactly. Somebody who's hoovering every single test email that's going out in the world.
Imagine all the data being leaked into that inbox.
Yeah, exactly. Yeah, so fraud, basically looking for people creating multiple accounts with, looser matching rules. So you can say these 10 people are pretending to be 10 different people, actually the same person. In one case that we did, we combined that with like geographical data matching because they were sending physical goods. And we discovered networks of fraudsters in little villages in the mountains of Spain that were ordering hundreds of thousands of euros of electrical goods. And yeah, we're definitely not.
And this was like a B2B website where they didn't have to pay up front on invoice?
This was B2C, so they were ordering it on credit with, I think, stolen credit cards.
Jeez.
Other use case that we've been working on recently is in the insurance industry.
Yeah.
If you've got multiple different insurance brands and you have people committing insurance fraud, they will quite often be creating policies in different insurers, changing their details a bit. You want to see, okay, these 10 people are actually the same person. Also, the regulators for insurance companies in each country have a list of fraudsters.
Yeah.
There's a lot of data sharing in the insurance industry. That's another kind of classic fraud prevention use case.
Wow. That's interesting though, because when I think about fraud on that level, sure, you can change your name, you can change, address. If you want to ship goods to yourself, that you would need an address that you're physically at or have access to. How does that work though with something like fraud? How do you, most likely they're using different names, different addresses, but how do you still identify them? Is it more than just the data that you filled in? Is there a lot of metadata that you are also trying to match these fraudsters or potential fraudsters on?
Yeah. So at the end of the day, it's dependent on what data can we access from the customer. And if somebody comes up with two completely unrelated identities, we're probably not going to be able to match it. So fraud is a multi-level approach or multi-layered approach. We need multiple layers to try and catch all the different fraud cases.
Yeah.
Reality is that fraudsters, they're not quite as smart, or a lot of them are not as smart as you might think. They will run through email addresses with patterns. So you can do pattern recognition on the email addresses. If you're using some kind of device fingerprinting, maybe you have the device fingerprint. Obviously, you're never going to do entity resolution based on an IP address alone, but you can use the IP address as like a kind of a block. It's effectively like a neighborhood or a city or something. So you're just dependent on what data the customer has. Wow. Particularly when it's fraud to do with real world things, there tends to be things that you can't change too much, like the geography, for example. So it might be a different address, but if you use the geolocation, you might realize, okay, those two addresses are actually 50 meters apart, even if they've got completely different street name and stuff like that. So at the end of the day, it's based on, could a human look at these two pieces of data and convincingly say that they actually belong together? If so, then the entity resolution system should be able to do it just within milliseconds and with an unlimited volume.
Wow. I think with fraud, it's one of the easier use cases if you do detect it, that you can actually, it justifies the investment in a solution like Tilores.
Yeah, that's true. Those sales processes are a bit easier because you do the test, you say this is how much fraud we'd catch, this is the cost, buy it.
And that's just a fraction then in most cases. The amount of fraud that I've been seeing online, reports about it, it's staggering. And I'm like, why would you want to burn yourself like that? But again, before we close off, just a quick question. What can we expect of Tilores in like the next 6 months? Do you have any exciting plans or features in development that you can already talk about?
Yeah, so that agent in the loop will probably come out. We have some more kind of graph-like features planned. One of the bigger ones, which is maybe not quite so exciting, but probably necessary, is making Tilores available natively on Azure and possibly Google Cloud. If you use the managed solution, it doesn't matter. But if you want to run it in your own infrastructure and you're on Azure, which I find is pretty dominant in the Netherlands at least, then we need to build an Azure version. It's a relatively simple port, but it'll take us a bit of time. So that's the sort of thing you can probably expect from us over the next 6 months.
Oh, super interesting. Well, thanks, at short notice. Thank you for jumping on this call. Like I said, I got that interesting question from someone on LinkedIn. Glad we were able to talk about the topic and learn a little bit more about where Tilores stands in the market and with its offering. Thanks for your time today, and enjoy the weekend.
Yeah, it's been a great chat. Thanks very much, Matthew.
Bye.